Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. Trigonometry lecture 6. For this lecture, I am using the work of my student Ms. Sharika Batul of class 2020, the Lyceum. An important advice for me and for everyone, we should be soft to others. List of important questions. Question number 1. Before solving this question, before explaining the solution of this question, I would suggest you all that you must watch all my lectures on YouTube regarding this chapter to understand the concepts of this chapter comprehensively. Well, prove the identity. This is an important identity, and this is important because of this 4 theta. When we have 4 theta, then we have to use double angle twice. So here we have to use double angle twice. This is the first time we are using double angle. The formula is 2 cos squared 2 theta minus 1. And here we have to use double angle just once. This cos 2 theta will become 2 cos squared theta minus 1. Since we need our answer in the form of sine, so we could use sine form here, 1 minus 2 cos square theta, but the student used 2 cos square theta minus 1 here, and later on she converted this into sine. It's better to convert this directly into sine form, 1 minus 2 sine square theta. Well, here we have to use double angle again. Cos 2 theta should be in the form of sine, 1 minus 2 sine square theta. You should skip this step. So cos 2 theta will be 1 minus 2 sine square theta whole square, and the rest of the things are copied. Minus 4 is here, and this cos 2 theta is 1 minus 2 sine square theta. And by simplifying, you just need to expand this by means of a minus b whole square, and you will be able to prove this. In this question, the important thing is use the correct formula for cos 4 theta and use double angle formula here twice. Sorry. The second part is of integration. Using this result, that means you must use this result. Meaning you need to bring this 8 here. You have to make sine 4 theta subject from this identity. So when you will make sine 4 theta subject from this identity, you will get 1 upon 8 here, and the rest of the things are here. The integral of cos 4 theta is sine 4 theta upon 4, cos 2 theta is sine 2 theta upon 2, and 3 theta. And by applying limits, you can get the answer. I'm sorry. Question number 2. A simple question. Simultaneous equations. In fact, use sum of angle formula here. By using sum of angle formula here, this is tan alpha plus beta. So by using sum of angle formula here, we have this thing. And then you just need to replace tan alpha by 2 tan beta here and here. And just do cross multiplication, get this quadratic equation, factorize this equation, and then you will get 2 values of tan beta. And this value is -1. This is -1. So this must be in second quadrant. This tan, because it's according to domain, you can work in first and second quadrants only. So beta is 135 and beta is 26.6. Make sure you give your answer up to 1 decimal place when angles are non-exact. When answers are non-exact, then in degrees, always give your answer up to 1 decimal place. Now we need alpha. So first substitute tan beta minus 1 here. Use tan beta minus 1 for this equation. So this will be minus 2, and this will be the answer. and then use tan beta half. We had two values of tan beta, -1 and half. So this is the value of alpha. I'm sorry. Now the next question is, this question is very simple. Question number 3. You should use a double angle formula here of the sine form, because this is sine. What if we had cos here? Then we would use this formula here. So whenever you use double angle formula, make sure you check the other function, the function with power 1 and with 1 theta angle. This is sine theta, so use this formula here. And you will get this quadratic equation. After factorization, you will get two values of sine, and you can easily get the answers. These are the final answers. I'm sorry. Question number 4. Cos 3x minus x, cos 3x plus x. First, you need to expand these two separately by using sum of angle formula. So by using sum of angle formula, we have this result for cos 3x minus x, and for cos 3x plus x, we have this result. Now we need to just subtract these two results, this and this, because of this negative sign. Since we have negative sign here, so we need to subtract this and this. This will become cos 2x. This is cos 2x. And this is cos 4x. And since we have cos 2x first and then cos 4x, so we need to write this first and then this at the second time. So this will become cos 2x, this will become cos 4x, and these two terms will be cancelled, and here we will get 2 sin x 3x, 2 sin 3x times sin x, and by dividing this 2 here on the left hand side, we'll get the answer. And integration, we just need to use this form. Replace this entire thing by this form, by this thing, and just integrate cos 2x and sin 4x. I'm sorry. Question 5. An important question. In this question, the use of calculator is not allowed. So this is cos alpha 3 upon 5. With the help of triangle, in first quadrant, we can get the value of sin alpha. And in fact, tan alpha as well. So this is 3 and this is 5, so this will be 4. So we have the value of sin alpha and tan alpha as well. I'm sorry. So first we need the answer of sin alpha minus 30. So by using sum of angle formula here of sine, we have this result. Now just substitute the value. Sin alpha is 4 upon 5, cos 30 is the root 3 upon 2, cos alpha is 3 upon 5, sin 30 is half. This is the final answer. Tan 2 alpha. This is the formula of tan 2 alpha. You can check the formula in MF 19. It's 2 tan alpha minus 2 tan alpha upon 1 minus tan square alpha. Now just substitute tan alpha here. 4 upon 3 ka square here. This is the answer. Now we need tan 3 alpha. Tan 3 alpha can be written as tan 2 alpha plus alpha, because we have both the answers. We have 2 alpha, we have alpha. So write tan 3 alpha as tan 2 alpha plus alpha. Then use sum of angle formula of tan 2 alpha plus alpha. This is the formula, sum of angle formula of tan, and then just substitute the values, and this will be the final answer. You should use MF19 while solving the questions. I'm sorry. I'm sorry. This question is very simple. We just need to use sum of angle formula here. This is the sum of angle formula of tan. It's here. Just do cross multiplication, get the quadratic equation, use quadratic formula, and let me do the correction here. This is tan x. This is tan x. This is tan x. Because the subject of the equation is tan x. So we have 15.7 degrees and 119.3 degrees. These are the answers. We had to work according to this domain. Sorry. Next question is question number 8. Very important question. Express under root 6 cos theta plus under root sine theta in the form r sine theta minus alpha. R is positive, theta alpha lies between 0 and 90. Give the value of alpha up to 2 decimal places. So the formula of R, when we have cos here, since we have cos here, therefore the coefficient of cos on the left side will be A. This is A. What if we had sine here? Then this would be A. This is the way to select the value of A. Since this is A, therefore this will be B. And the formula of R is A square plus B square. This is R. And the formula of alpha is tan inverse B upon A. So this is the value of alpha up to 2 decimal places. By substituting the values of alpha and R into this equation, we will have this equation. We can get this equation, in fact. Make sure you substitute the value of R here and alpha here. This means express. So this is the answer of the part 1. After getting the values of R and alpha, make sure you substitute both the values into this equation. That will be your answer. Don't leave your answer here. Give your answer in this form. Now, this is the part A. Under root 6 cos theta plus under root sine theta minus 4. We need the smallest positive angle. So we just need to, minus 1. Cos is minus 1 at 180 degree. Here. So the answer is 180. So by theta we have this. By shifting 52.24 on the right hand side, we'll get this answer. So this is the way to solve this part. Now here we have half theta. Now make sure you use the correct form here. This will be half. Theta is replaced by half theta. Sorry. So when theta is replaced by half theta, this theta will become theta upon 2. Let me explain this over here. Since we have half theta here, therefore this theta will become theta upon 2. When this will become theta upon 2, then this will become theta upon 2. And leave this as it is. So we just need to write here theta upon 2 here. And then this will be 3 upon 4. Since cos is positive, so it can be in first quadrant and fourth quadrant. Since we are working for the smallest angle, therefore we need to work for both the angles. We need to get this answer and this answer. So we have 2 values of alpha. This is 41.4 and this is negative 41.4. You don't need to write negative here because I already have mentioned sign, but remember this is negative 41.4, it's here, and this 41.4 is here. So by shifting 52.24 on this right hand side, we'll get two values of x. We'll get two values of, in fact, half theta, 93.64, 10.84. So by multiplying 2 on the right hand side, we'll get 21.7 as the smallest answer. This is the smallest answer. You just need to ignore this answer, because in the question it was mentioned, find the smallest positive angle theta. This is the smallest positive angle theta. Whenever a question says find the smallest positive angle theta, you just need to observe the quadrants. Since cos was positive, so it was in first and fourth quadrant, and you just need to get both the answers and then compare which answer is the smallest. This was the smallest answer. Sorry. The identity of cos 4 theta plus for 4 cos 2 theta, and we have to prove this thing. We have to use double angle formula twice here. Since we need our answer in the form of cos, so we will use cos form of double angle. So cos 4 theta is cos 2 theta, 2 cos 2 cos, this will be 2 cos square 2 theta minus 1. This student wrote this thing directly. Let me write cos 4 theta formula here. This will be 2 cos square 2 theta minus 1. Since this student is very smart, so she took this to common, she made this as whole square over here. 4 cos 2 theta, 4 is here, so this will become cos square theta minus 1. This 2 is nothing. Again, you have to use double angle formula here. So this will become 2 cos square theta minus 1, and this power 2 is here. This is the double angle formula of cos 2 theta. Make sure you use the formula carefully here. And you just need to expand this bracket by means of a minus b whole square, and then you will get the answer. Second part of this question is very simple, and we need to solve this equation. In fact, we won't solve this, we will solve this thing. So 8 cos power 4 theta minus 3 is equal to 1. You know, whenever we take root for even index, we always write plus minus. This is the root for index 4. Here is index 4. Since cos is in both the quadrants, in first and fourth, therefore we have to mention both the answers. We have to write both the answers. This is 0.572 and this is minus 0.572. This arrow means negative 0.572. That is why we have two answers, plus minus 0.572. The next part is integration. We have to integrate cos power 4 theta. We will not integrate cos power 4 theta. We will first make cos power 4 theta subject from this identity, and then we will integrate the left hand side. So this thing is from the identity, and then you can easily integrate this. Cos will become sine 4, and you know this is very simple integration, and this is the exact answer. I'm sorry. Next question is 11. Show that the equation, sorry, this equation can be written into this form. We have to show this. Now, this part involves a lot of algebra, a lot of calculation. You must have enough practice to handle questions of this type. Tan 60 plus theta. Use the sum of angle formula here, sum of angle formula here. Now substitute tan 60, it's root 3. Tan 60 is root 3. Now you just need to take LCM. Take the LCM carefully. So denominator will become a square minus b square. And you should use brackets here. To avoid the careless mistakes. When you will take LCM, you will multiply this 1 plus root 3 tan theta with this and this with this. Make sure you do the multiplication carefully. And then you will finally get this thing. This is of this form. And by comparing this, this is k. Let me check this. 2 root 3 tan square theta is fine. K, alright, it's fine. Alright, so this is the answer of part 1. Now, by comparing these two parts, see, k is 3 root 3. So you need to substitute 3 root 3 here. K is 3 root 3, substitute this here and get the, make the tan square theta subject and then get the answers. This is important. You should understand that k is 3 root 3 by comparing these two equations. These are the final answers. This question is also very important. I'm sorry. The second part, because we have 2 theta here. The first part is express this into this form. Since we have cos here, therefore this coefficient of cos 1 is a and b is 3. The formula of r is a square plus b square. Leave r as it is. Give the value of r as exact form of r. Because we need exact value of r. So this is the exact value of r. And alpha is b upon a tan inverse. 2 decimal places because it's mentioned. Substitute r here and alpha here. This is the final answer of part 1. Make sure you do the substitution into this equation. Always substitute alpha and r into equation 1 here and here and give your answer into this form. Hence solve the equation. See, x is replaced by 2 theta. So you need to replace x by 2 theta here, here and here. Then you will get this form. Now you just need to change the domain. Make sure you change the domain. The domain is 0 to 90. So when you will change the domain, I'm sorry, it's 0 to 90. So you have to make it as this angle. So this will be 0 to 180, 71.56, 71.56 should be here. And this will be, I'm not sure, this will be, I guess, 108.44. So this negative domain means you need to work in clockwise direction, and this positive means you need to work in anti-clockwise direction. This is very important. Always make the domain as this angle. So by taking cos inverse here, this is not right. Don't write this as 2 theta this thing. Whenever you take inverse, always replace this angle by basic angle. Basic angle is equal to cos inverse 2 upon root 10. Then when you will take inverse, you will get this value 50.768. This is 50.768. So one answer is here, 50.768. It's negative, and the other answer is 50.768. So there are two possibilities: 50.768 in first quadrant, 50.768 in the fourth quadrant. Then you just need to work for theta. Theta, you need to bring 71.56 here and here, and then just find theta. These are the required values of theta. This question is important, question number 15. It is given that tan 3x is equal to k tan x by first expanding tan 2x plus x. Sorry. So first we need to expand this by using sum of angle formula. So tan 2x plus x is this, and this tan 2x plus x is equal to k tan x. So replace tan 3x by k tan x here. Here you need to use double angle formula, and here as well. So use double angle formula here and here. And make sure you handle the calculations carefully. Here you need to take the LCM. This is just multiplying with this. This is fine. Here you need to take the LCM. So when you will take the LCM over here, you will get 2 tan x plus tan x times this bracket. It's here. And when you will take the LCM here, this one will become 1 minus tan square x. This is 2 tan square x. And you just need to cancel these two and bring this here. And then you will be able to get the form, this form. Hence solve the equation. So when k is 4, so you need to substitute 4 here. And you will not solve this equation. In fact, you will solve this equation. So by substituting k4 into this equation, you will get this thing. And when you will take a square root, you will get plus minus, and these are the final answers. Show that when tan 3x is equal to k tan x has no real roots when k is 2, you need to substitute 2 here into this equation. You will get this thing. And see, we have negative sign in the root, so there will be no real roots. Negative means no real roots. I'm sorry. This question is also important. By first expanding cos x plus 45 express this into this form. So it's very simple. You first need to simplify this by using sum of angle formula. This is the sum of angle formula. Copy minus root 2 sin x here. Then cos 45 is 1 upon root 2. Sin 45 is 1 upon root 2. Then you just need to take LCM of these two. you will get minus 3 root 2 upon 2. Now this is the simplified form. Now you can get the values of a and b. Since we have cos here, therefore this is a and this is b. Make sure you take b positive. Don't take b negative. We always take a and b positive. So this is positive. Sorry. This is also positive. We always take a and b positive for r and for alpha. So a is this and this is b. R is the under root a square plus b square. So this is the value of r. This is the value of alpha. And you just need to substitute these values over here, here and here. So the answer will be r is root 5 cos x plus 71.57. This is the answer of the part 1. Sorry. Now the next part is we need to solve this equation. Just equate this entire thing to 0. 2. It's here. And make sure you change the domain. The domain will be zero. This is x 360. This is the given domain. You make the given domain as this thing. Your domain should be like of this form. So 71.57 x plus 71.57. This will be, I guess, 31.57. This means you have to work in first quadrant twice. That is why we have this answer. We work in first quadrant twice. We got alpha 26.57. This is the value of alpha 26.57, and tan is positive, so we got this answer, then this answer, and this answer. We need to ignore this answer because this answer is not in the domain, this domain. So we have two possibilities, this and this. I'm sorry, there was not tan, this was cos. Let me correct this thing. The function is cos, not tan. So this answer, and this answer. So we have three possibilities. But the first possibility is not right because domain is 71.57, so this answer must be rejected. So we have two possible answers, this and this. Now we need to bring 71.57 on right hand side. These are the final answers. This 315 must be 315.0. This is the right answer because non-exact answers in degrees up to 1 decimal place. This identity is very simple. You can easily prove this identity. Cot theta is cos upon sine, tan is sine upon cos. Take the LCM, this will become 1, and you can replace this by double angle formula, which will become 2 cosec 2 theta. And to integrate cosec 2 theta, you need to replace the value of cosec 2 theta from the identity. It's cot theta tan theta. You know, we can easily integrate cot theta and we can easily integrate tan theta. I don't know what did this student did over here. Let me cancel these steps. These are wrong steps. See, cot theta should be replaced by cos upon sine theta, and this should be replaced by sine theta upon cos theta. It's here. And by using basic formula number 2 of integration, we can integrate this. This will become ln sine theta. This will become ln cos theta upon minus 1. And you just need to apply the limits. Well, this is all from this chapter. This chapter is almost over. I tried to discuss the important questions of this chapter. I hope this lecture will help you all to understand how to solve the questions of trigonometry. But again, my advice to all of you, you must watch all my lectures of this chapter on YouTube to understand the concepts of this chapter in detail. And the advice is be proactive. Allah Hafiz.